And so everybody, I guess we are a couple minutes after the hour. Thanks for hanging in there. We just had a couple of issues getting Glenn's sound and getting Glenn's presentation up, but now we're there. So welcome. This is Joe Armstrong and the December Power Systems Virtual User Group webinar, the last of the year. I want to wish everybody Merry Christmas and a Happy New Year now, and we'll get going with our session. So today we're going to talk about PowerVC. We've got Glenn Corneau with us. Glenn is part of our Washington Systems Center, previously known as the ATS group. Glenn's been working on AIX and power architecture. God, it must be 20 years now, Glenn?
Yep, over 20 years.
Over 20 years. And he works on systems management and high-performance computing, and he's worked on things like GPFS, which is now renamed something else. And it's part of the management stuff. You know, we have PowerVC, which is really for our cloud, which is the foundation for IBM's on-premise cloud for power, built on OpenStack. So we're gonna talk about that. It's really the foray into the cloud, which if you're working in IT these days, you've certainly heard the cloud for quite some time now. IBM's very deep into cloud and cloud business, both on-premise cloud and public cloud, and most companies have a kind of a combination, what we call hybrid cloud strategy. So I think this will be very relevant. I had a lot of requests for PowerVC, in fact, if I look back and people put on the survey what they'd like to see in future sessions, and a lot of requests for PowerVC. So I hope this helps. If you have questions, please put them in the Q&A panel. I'll be watching that, and we'll see if we can answer some of those. If not, if I don't answer them while we're talking, we'll get to the end and we'll go through with as much time as we have. We'll go through whatever questions are out there. And then when I am recording this session, the presentation materials are out on the wiki, and whenever I get the recording done, WebEx it's actually quite slow in getting things like the recordings and stuff available, but I'll put it out on a link on the wiki as soon as it is available. So with that, I'm going to turn this over to you, Glenn.
Well, thank you very much, Joe. Hello, everyone. And hopefully you can still hear me all right. Is that correct?
I can hear you fine.
All right. I'll let you monitor the queue. So yeah, as Joe mentioned, we're going to talk today about IBM PowerVC, or Power Virtualization Center. And with that, let's just go ahead and jump into things here. We're going to start off just really high level, talking a little bit about the Power Cloud Management Stack. There are quite a few moving pieces and parts here. We're going to focus obviously on PowerVC today. Although as we talk through this, if you haven't seen a PowerVC presentation or haven't seen one recently, then you may or may not know that there's this other component that lives down in the Power VM space known as NovaLink. That's kind of an important part of our management of virtualization management of our power systems. We're going to go through the different editions of PowerVC that are available, talking about the features and the functions that are there. We're going to touch a little bit on KVM on Power. So this is not our older product, Power KVM, but basically support for the community or the third-party vendors, or well, I guess soon to be IBM vendor with the Red Hat acquisition in line, their support for KVM in the Linux operating system. I've got some information on requirements down at the end, and hopefully everything, knock on wood, will go well, and we'll be able to do some live demonstration of a PowerVC system we have running in our lab today. And with that, let's go ahead and kind of move forward. So when we talk about the cloud management stack, I'm not going to go into depth on every piece and part on this slide here, but you know, when we think about our power systems today, we really kind of have two classes of power systems. We've got the IBM branded systems, what we would consider more of our classic enterprise power systems, running Power VM, supporting all three of our standard operating systems on those servers, AIX, IBM I, as well as Linux. And then we've got our open power partner systems. These are ones that we've developed in conjunction with our open power partners. They're all Linux-based. And when we talk about virtualization management in that space, we're talking about utilizing the kernel virtual management, or KVM. And so, and now I've got listed Docker down there and a tiny little icon. We're going to touch upon that kind of at the end when we talk about IBM Cloud Private and PowerVC. But when we talk about on-premise local cloud management, PowerVC is going to be the product. It is built on OpenStack. So OpenStack, if you're not familiar with it, you can kind of almost think of it as a cloud operating system. It's a community-driven effort. It's been around for a number of years now, but it's really taken over in the private cloud space, or the on-premise cloud management space. But we don't live in a vacuum. So we have to be aware that even if we're talking about managing your on-premise power-based cloud, you're probably going to have higher level products that need to be able to talk to that cloud, be able to do things like kick off a provisioning of a brand new virtual machine and things like that. And so there are many products that can do that. Our PowerVC software comes with northbound REST APIs that we publish and make available for customers and other vendors to utilize. And so we've partnered with VMware, and we'll talk a little bit about that. Our own IBM Cloud Private product can talk to PowerVC, utilizing some technology under the covers known as Terraform. If you're interested in that, I actually included a link down at the bottom of the ability to use Terraform to actually deploy and create an IBM Cloud Private configuration through PowerVC, and do it in just, well, relatively a few minutes. Other products like SAP, their landscape virtualization management suite can also talk to PowerVC and drive implementation and monitoring and management of the PowerVC based on-premise cloud. This is kind of a wordy chart compared to all the pictures we had on the previous slide. And really, I just wanted to touch upon it mainly to talk about the bottom two boxes. When we have platform management down at the bottom, we're thinking about the hardware. If you're most folks on the call or on the replay are very familiar with HMC managed power systems. Maybe not so familiar with NovaLink managed power system, but we're really talking about managing the virtualization layer as a component. And I did include KVM kind of in a blue box over on the side, as KVM isn't quite really a hardware management component, but it is a virtualization layer. And as we'll see as we go through this, PowerVC can talk to both the traditional HMC as well as the KVM hypervisors for managing power systems. And so we're gonna dig into what PowerVC brings to the table with regards to image management, deployment, more advanced resource pooling and optimization and dynamic virtual machine placement. And we're also going to touch upon the IBM Cloud PowerVC Manager Edition. This is bringing self-service provisioning, multiple projects, and multi-tenancy to our PowerVC implementation. And as mentioned before, we can integrate upstream with other products like VMware and even IBM Cloud Private Cloud Automation Manager. Now this is my one slide on VMware. If you're interested in more details, I'm sure we can work with Joe to bring someone on board who can talk to this in greater detail. A few years back, actually about 2 years ago, a little 2.5 years ago, we had our first announcement with VMware for their VMware vRealize automation product, which essentially allowed VMware's product to go ahead and talk to PowerVC and provision brand new AIX, Linux on Power, or IBM i virtual machines, and do it through the PowerVC interface. Really through the PowerVC software. They expanded that over the years, bringing in their vRealize orchestration piece, which does more than just creating a brand new VM. It can actually orchestrate the installation and the configuration of multiple VMs. And then just recently, as you can see from the announcement and the link down at the bottom of the page, we've continued to expand that relationship, bringing in their vRealize operations suite of software to be able to manage power systems. And this is more than just PowerVC. It's HMC management, it's VIOS monitoring, it's monitoring and full operations of the individual operating systems running inside those VMs. So we've continued to go ahead and work with VMware, since they have a very large presence at all of our customer locations, and making it easier for, making Power Cloud just part of their cloud infrastructure. I said I was going to talk a little bit about NovaLink, and we're not going to dig into it, but it is the underlying basis for a lot of our scalability and enhancements in the management of Power VM systems under PowerVC. And when we think of NovaLink, it is essentially a new path for on-host virtualization management. If you're familiar back in the day with a product known as IVM, or Integrated Virtualization Manager, that was kind of like a virtualization focal point and a VIO on one single system. In the case of Power VM NovaLink, NovaLink is its own separate utility partition that runs on your Power server. One NovaLink partition per Power server today, with plans of looking at highest. Yeah, folks could go on mute. I understand we got allergies down here in the Central Texas area as well. No fun.
Yeah, I thought everybody was muted, so I'll have to see if I can do something about that.
Yeah, no worries. But one of the key items that NovaLink brings to virtualization management for Power is scalability. We have a limitation of only 30 physical hosts under a single PowerVC server if those hosts are being managed through PowerVC using an HMC. With NovaLink, we can scale that up to 200 hosts and up to 5,000 virtual machines under a single PowerVC server. So in essence, it's a set of software packages that we provide. They're available either from IBM or you can download from the web. These packages get installed into an Ubuntu or a RHEL Linux LPAR on the system. And that NovaLink partition takes over all the virtualization management tasks for that particular physical system. There's no graphical user interface for NovaLink. It's strictly API-driven or perhaps command line driven if you're so inclined. The idea being is that PowerVC is going to talk to the APIs running inside the NovaLink partition to be able to handle all the virtualization management on the box. Now, non-virtualization management pieces, things like non-disruptive firmware updates or your hardware maintenance analysis procedures, serviceable event management, all those continue to happen from your HMC. So the HMC still has a place in the Power world for our non-LC type servers, our non-open Power servers. And so it can still be there on the side handling those non-virtualization management tasks, but the virtualization management gets taken over by NovaLink. Now we can't put these into what we call co-management mode. So the HMC is connected, it sees the state of the server and all the LPARs and the virtualization state, but it's basically in a read-only mode. And we can switch that mode, the management back and forth between NovaLink and the HMC to be able to get some of those specific tasks accomplished, like the non-disruptive firmware update, etc. If you want more details on that, certainly can provide those, but this is just kind of a high-level view of what NovaLink brings to the table. So switching back kind of to PowerVC, some of these things were mentioned, and you may already be familiar with these if we just had to create a quick bulleted list of things PowerVC brings to the table. First of all, it's, as I mentioned, it's built on OpenStack. It's a purpose-driven implementation of OpenStack. So you don't have to pull down the OpenStack packages yourself, build them, configure them to all the different components to talk to each other. We provide all this via one installation script, as well as one package, and that package can run on x86 Red Hat Linux, Power Red Hat Linux in both Big Endian and Little Endian formats. But these PowerVC features, capture and deployment, relocation, you can think of that as live partition mobility. we have, but it's enhanced above and beyond what you might get from a standard HMC's LPM capabilities. We've got policy-based VM placements along with optimization and rebalancing or perhaps movement of resources or virtual machines around your group of servers to maintain a certain CPU utilization load, for example. OpenStack has a twice yearly release schedule. PowerVC does as well, which means we're able to take advantage of all the new enhancements that come in the latest releases of OpenStack, as well as our own contributions as an IBM corporation to the OpenStack project from an enterprise perspective. But we've brought our own user interface, our own resource scheduler into this, as well as all the traditional RAS characteristics you would expect from an IBM software product with regards to logging and first failure data capture, et cetera. Now, unlike previous products, if you've ever heard of IBM Systems Director, I'll apologize up front for that. But we don't have an agent that runs inside the operating system for PowerVC. So we're really just concerned with managing the virtualization infrastructure and not so much with the operating system inside those VMs. So there's no agents to install. From a day-to-day perspective, we're talking about all the stuff you would do from starting an LPAR, stopping an LPAR, deleting it. What's nice about the delete is it's a full delete. And so when you go to remove an LPAR under PowerVC, he cleans up not only the LPAR definition on the server, cleans up all the necessary components within the VIOSs, as far as virtual fiber channel adapters, et cetera, cleans up your SAN storage zones, and the ones on the back end if you so choose. So it's a more complete delete than just what you may do at home from your HMC. We also include host maintenance mode or an evacuation mode. We'll talk more about that. And then volume management from a SAN perspective. So I know some of our marketing materials like to say storage management, but it's not really. We're just utilizing the storage in the same way that a day-to-day administrator of their power systems would do. They're going to be able to create LUNs, delete LUNs, map, and so on and so forth. We work both with SAN infrastructures, virtual SCSI, NPIV, as well as VIOS shared storage pools, and we'll talk about the file back disks that come with our software-defined storage piece as well. Other things that you're traditionally going to have in a Power VM managed environment, dual HMCs, we support that under PowerVC. Multiple shared processor pools, we can recognize those shared processor pools and respect those. So when you LPM and LPAR from one system to another, under PowerVC, he won't move it over there if there's not that shared processor pool or there's not resource in that shared processor pool. Active memory expansion can be implemented through PowerVC as well. So those underlying traditional Power VM features and capabilities, we're going to go ahead and recognize those and make those available if you want to use those in PowerVC. This is kind of just a reiteration of what we talked about on the previous page. And really, the key bit to me is this little VM mobility component right in the middle there of the diagram. If you've got an environment, whether or not you use live partition mobility, but if you've got an environment that is LPM capable, so you've effectively met all the rules, all your resources are virtualized, nobody owns physical adapters, et cetera, then you have an environment that can be utilized with PowerVC. So it's not for the systems where you've got dedicated LPARs with adapters. That's not what PowerVC can manage. This is all about virtualization management. And I mentioned before capture and deploy, kind of one of the key components of PowerVC, and also really works to show the power of utilizing a single user interface for doing some of these multi-step tasks that administrators and or storage administrators are going to do on a day-to-day basis in managing their power systems. So if you think of a traditional Power VM environment, it could be HMC or NovaLink. We'll talk more about that, but for all intents and purposes, it doesn't matter. Somewhere out there in your environment, you've got a PowerVC server running. It's able to communicate with your HMCs or with your NovaLink partitions. You've got a SAN infrastructure and a storage infrastructure that are tested and supported with PowerVC. So from a SAN perspective, we're talking Brocade or Cisco SANs. And from a storage perspective, IBM storage, of course, is going to be supported. We have support for EMC. We have support for Hitachi built into PowerVC. But we also have what's called a pluggable infrastructure. So if a third-party storage vendor has a OpenStack Cinder driver that works with fiber channel-based SAN, then we can bring that and plug that into PowerVC and utilize a piece of storage, for example, non-Hitachi or non-EMC, that you want to utilize with PowerVC. And we have success in this environment of managing, other types of storage. Our lab services folks are very adept at working with customers and getting those things up and running and going. So we've got our PowerVC server out here. It's just an operating system. It's a Red Hat operating system with the PowerVC software installed. There are some instances, for example, one of the EMC storage drivers only runs on x86 Linux, so it would tie that to an x86 architecture. But from a PowerVC perspective, we're agnostic. We don't care where it runs as long as you've got the CPU and the memory resource to use for that PowerVC server. Could be physical or virtualized. You go ahead and after you've got everything all up and running, you go ahead and point your PowerVC server, well, technically through your HMC, but the idea is you've got servers, you've got virtual machines. We want to bring those virtual machines into a PowerVC infrastructure. We use the task known as manage. And once we do that, it shows up in PowerVC as a virtual machine. So I'm using the term virtual machine and LPAR interchangeably. The technical term in PowerVC, everything is called virtual machines. So we'll see a representation of that virtual machine in the PowerVC interface. And the idea being is, let's say we want to create a brand new libraried image, a new golden image that we're going to use to deploy all our new AIX LPARs as an example here. So I've got the virtual machine defined in PowerVC. I've got my AIX operating system out there. I've customized it with whatever patch levels, whatever additional code I need to make it work in my environment. And then rather than using traditional AIX NIM methodologies, which is a file-by-file backup, the PowerVC idea of capture is that we're going to go ahead and talk to the storage array and tell that storage array we need to create new copies of all these LUNs that were defined to that particular virtual machine. So if we've got two root VG disks and a data VG disk, well, we can capture that virtual machine, and he'll go ahead and make copies on the storage array of those two root VG disks and that data VG disk. And he'll copy those images, and he'll just kind of set them aside on the storage. We'll have that image representation within PowerVC. And then when we want to go ahead and create a brand new LPAR, we're going to go ahead and use the task known as deploy. We'll take a look at that in the live demonstration. That deploy task is going to go ahead and do all the things that you do on a day-to-day basis when you create a brand new LPAR. We're going to talk to the HMC, tell the HMC, create the virtual machine on the particular host. We're going to, create all our virtual fiber channel adapters if we're doing NPIV, which most folks are. We're going to talk to our storage array. We're going to say, hey, make new copies of those image copies that we already had in the on the storage array. So we make new copies. We talk to our SAN infrastructure. Since we now have our virtual fiber channel WWPNs from creating those on the HMC, through the HMC, we've got our WWPNs. We've got our storage array information. We can go ahead and create new zones for the brand new LPAR. We're going to power up that LPAR, and upon its first boot, we're going to use customization technology that comes with Cloud init, which is kind of the de facto standard for post-deploy customization out there. And that's going to go ahead and read some configuration information that we defined when we kicked off the deploy, like what are my network IP addresses and host names? And he'll go ahead and configure the local host names and IP addresses. And so it comes up as a unique, brand new virtual machine with a unique host name, a unique IP address. And that cloud init post-deploy customization technology can be completely extended in your particular environment. So if you use Ansible, for example, or other, configuration management tools, you can configure, or Chef, as an example, you can configure the cloud init technology to configure Chef so that when this thing boots up and gets configured, he goes ahead and talks to your Chef server and pulls down whatever new updated configuration information he needs to. So it's very very customizable, very extensible, and most importantly, it's OS agnostic. We're not using NIM for this process, and hopefully, if you've got a decently fast storage array, it's pretty darn quick. I can hit deploy, and usually within 3 minutes or so, I can log into the LPAR and I can start doing things with it. So it's pretty fast. As I mentioned, NPIV is supported. Classic vSCSI is also supported as well, and then shared storage pools are supported. And we'll talk about the software-defined storage or the file-back storage a little bit later. All right, so when we're talking about managing all these servers, well, maybe I just don't have a flat environment. Maybe I've got different purposes for the different servers in my environment. I can utilize the PowerVC concept of host groups to put labels, if you will, on the servers in my environment. So we call a physical server a host. Some folks might call it a frame or a KEK, but I prefer server because that physical server that more accurately represents what a particular machine type model is. And we can add hosts into host groups. Hosts can't belong to more than one host group, but you can think of these as kind of dashed line domains or subdomains in your environment. So when we go to deploy, we can say just deploy something into my Power 8 host group. Based on the policies we've put in place, he's going to choose a particular server in that host group, and that's where he's going to create that brand new LPAR. If we're going to do a PowerVC instantiated live partition mobility operation, it's going to happen within that host group, things like that. If we're going to rebalance the LPARs based on CPU utilization, it'll happen within that host group. So the host group is an important concept. You don't have to use it. You can leave everybody in your default host group, but the capability is there if you want to utilize that. Now, I mentioned a policy when we go to deploy a virtual machine or relocate it. We have a number of policies that are available with PowerVC. We've got simple ones like packing and striping, which say, fill up the first server first. When that one's full, go on to the next one. Or just every brand new virtual machine I deploy, I put it on the next server within the host group. Pretty straightforward. I've got CPU and memory balance policies as well. So based on CPU allocation, not utilization, but allocation, pick the next server that's got the least allocated CPU, but it has enough space to fit the brand new virtual machine I'm going to deploy. Same thing for memory balancing as well. Now we do have a CPU utilization policy, so this gives us a rolling 15-minute average of the CPU utilization of the servers within the host group, and it'll utilize that for placement of brand new virtual machines or relocations, etc. Now, of course, there are some times you don't want two virtual machines on the same box. So we have anti-affinity rules that you can define that say, hey, these are part of a Power HA pair. I don't want these two on the same physical server because that would really become a single point of failure. So I can put them into anti-affinity rules. Or maybe I've got a database LPAR and an application LPAR, and I'd really prefer for the network communication between those two LPARs to be on the virtual Ethernet backplane through the hypervisor because it's pretty darn fast. So I can put those LPARs into an affinity rule. Now, these affinity and anti-affinity rules, they're soft, if you will. I can still log into my HMC, and I could do a live partition mobility operation of two LPARs that are in the anti-affinity rule, and I can move one of them onto the same server as the other. PowerVC is not going to stop you from doing that. It will put up a flag that say, hey, by the way, this system is out of compliance with your rule set that you've put in place. So it will let you know about that. As I mentioned before, we've got this concept of maintenance mode. You can think of it as a host-based controlled evacuation. So it's all designed around live partition mobility. It is supported on all the hypervisors that PowerVC supports, but as it might not surprise you, there is no such thing as migration between hypervisors. So there's no migration of a virtual machine from PowerVM to KVM. That's not possible. The host group policy determines where things end up, and this is completely administratively driven. So this is not an automated fashion. The idea being is I'm coming along, maybe I want to make a firmware update for that first server on the left-hand side. I'm going to go ahead and hit the maintenance mode operation, tell him to actively move all those virtual machines to other hosts in my host group, and he'll go ahead and kick off that LPM move and move those LPARs around. So it's completely administratively driven. It's not designed for failure modes. Now, one thing we don't have in PowerVC at this time, but everyone is certainly welcome to upvote this on the request for enhancements page for PowerVC, is a move back button. So if I go and I now take this system out of maintenance mode, I've done whatever disruptive operation I needed to do on it, I'm going to either have to manually move LPARs back to that or maybe initiate a rebalancing operation that's going to move LPARs around. But there's no move back button at this point in time. Now, I can optionally not move LPARs, or I can just mark a system as unavailable for brand new LPAR moves or brand new LPAR deployments if I want to. So this maintenance mode kind of has two different flavors, if you will. Now, for folks who are thinking of a failure-based movement of LPARs, that's the automated remote restart. Now, this is built on simplified remote restart capability that comes with our Power 8 or Power 9 servers and our HMCs. It also happens to be there in NovaLink as well. But this is the idea that a server physically goes down in a disruptive manner, and LPARs are recreated on other servers, and then they're powered back up and they boot, and you run whatever checks you have to do. So this is not using live partition mobility, but the nice thing about doing this from a PowerVC perspective is, well, number one, PowerVC can automate this kind of operation. We have customizable timers that you can set up in your environment to say, hey, if this host is gone, I'm sampling him every 5 minutes and he disappears after 15 minutes, go ahead and initiate the automated remote restart function. So if I'm doing this manually, I have to log into my HMC and I have to run a command, and I have to tell him where he's going to put those particular LPARs. With PowerVC, he's going to determine where in the cluster of servers within the host group he's going to go ahead and put those LPARs and move them around. Now, the hosts must be remote restart enabled. That's a checkbox that you do on your HMC, and your individual LPARs must be remote restartable as well. That's a particular LPAR option that you can choose to initiate a remote restart operation. Now, in both maintenance mode and in automated remote restart, I can basically say, I don't want to participate in these operations. So I can mark an entire host as non-participatory for both maintenance mode and automated remote restart. I can mark individual virtual machines in the case of automated remote restart as don't participate. I don't want you to automatically restart this LPAR if this host goes down. Maybe it's a Power HA pair, so there wouldn't be a need to do that. So there's a lot of customization capabilities under the covers here, and we're just kind of giving you the high-level view of everything. Now, I've mentioned rebalancing or optimization. This is the capability known as Dynamic Resource Optimizer within PowerVC. And we've got two modes here as well. We've got a CPU utilization mode, CPU or memory utilization mode that utilizes live partition mobility under the covers. So if I set a threshold on my server that says, hey, if I'm exceeding 85% CPU utilization and I'm doing that over this 20-minute period, then go ahead and kick off an optimization run. And he's going to look at other systems within the host group, see who's got, less CPU utilization, and initiate a live partition mobility for the, effectively the smallest LPAR that could move that would bring our utilization down. So he's going to use a little bit of logic there in trying to determine what to move around within the host group to bring my CPU utilization below the threshold that I've set. If I'm running in a completely enterprise power server environment where I've got power enterprise pools, so I've got this ability to activate on-demand CPU resources, I can actually integrate with that for our HMC managed servers. And instead of live partition mobility moving LPARs around, I can go ahead and just activate CPU resources on demand or deactivate based on that utilization number. So I've got that capability as well. Now I can run this in an advisory mode. I don't have to actually do anything. I can just set it up and say, hey, tell me what you would do if I enable this in my environment with these particular thresholds. I've also got a scheduling capability, like, hey, maybe I don't do this during prime shift hours, but I just do this during off shift hours, or vice versa. So I could set up a time calendar that says, hey, dynamic resource optimizer is only available during these particular time periods. Now, for using NovaLink, we do also have a memory-based utilization threshold that we can utilize instead of CPU-based. For just doing HMC-based management, it's all CPU utilization. So that's quite a bit of capability. That's most of it in the standard edition of PowerVC. So if we kind of work our way up the edition ladder, we have what we were kind of hoping was going to be called Cloud Edition, but they ended up calling it IBM Cloud PowerVC Manager. And this is really, from a code perspective, a small addition to the base PowerVC Standard Edition, but it really brings a lot of capability with regards to managing my environment in a fully multi-tenant fashion, and also bringing a self-service component here as well. So with this allows us to set up multiple projects in our environment, and these projects, as we'll see on a following slide, particular resources belong to projects. I won't say physical resources, but virtualized resources belong to projects. We can set up the capability for self-service users to be able to log into PowerVC and to request resources. So if you think of, other cloud providers where you can log into a website and go, I want a medium-sized virtual machine, which means, X amount of CPU, X amount of disk, X amount of memory, we can do a similar concept in your own private on-premise cloud with PowerVC and IBM Cloud PowerVC Manager. So I can log in, I can request resources, I can have administrative approvals put in place. So I may request 10 LPARs of a certain size, but my administrator or my cloud administrator gets to approve or disapprove those particular resources. And like other places, maybe you're doing this in an environment that's strictly development-based. And so you've got developers requesting virtual machines all the time, and if you let them just keep on doing this, they'll never get rid of things. They'll move on to the next project and they'll leave their old virtual machines lying around. Well, I can put in place expirations for these particular resources, and I can allow PowerVC to monitor those expiration dates, shut LPARs down when they've surpassed their expiration dates, and if I want to, I can even have them delete that particular LPAR after a given period of time. Maybe I can also set up a policy that says, hey, after things have expired, I will allow my users to request up to 2 more weeks of time so they can get their stuff off the virtual machine before it gets deleted. All this can be done through the graphical user interface quite easily. We've also got project level resource allocation monitoring, if you will, not utilization but allocation. So this user or this project allocated X amount of virtual machines, Y amount of CPU resources, Z amount of storage, and so on and so forth. And those project resource allocations can be viewed in the graphical user interface, but they can also be exported on the command line to like a CSV file if you want to. So when we talk about these multiple projects, here's a simple example, 3 different projects. If you want to think about it, your physical resources, your actual storage arrays, some of the host groups that are previously defined, and your networks, they're common amongst all the projects. So they're not project specific. But then individual users, virtual machines, the image template. So when we captured an image before, it created an image template. Those belong to the particular project. And then networks are kind of a special case because we can have networks that are specific to a given project, or we can have networks that are definitions that are shared across projects. And we're talking about networks here. PowerVC does not talk to our networking hardware. So we're talking about logical networks with regards to, IP address ranges, DNS entries, things like that. Or in the case of software-defined networks, these would be the virtualized networks that appear in SDN, but we're going to get to that in just a few minutes. So with all this capability, we've kind of touched upon some of this. It might be a little confusing as to what exactly we can manage with PowerVC. So I put a couple slides together to kind of summarize this. And if you think of most customers out there, they're running PowerVC. They've got HMC managed Power hosts, probably doing NPIV-based storage. That's the majority of customers out there. So that's what this example represents: is a simple Power VM host, traditional dual VIO setup. They're both connected to your network, and they're using some kind of sandbox storage. So as mentioned before, we can manage those systems through an HMC just fine under PowerVC. A couple of years back, we created this concept of NovaLink, brought this to the table. So this is still very traditional Power VM based. You can still have dual VIOs in this kind of configuration. It just means the communication path from our PowerVC server to the host, instead of going through an HMC, now goes through our NovaLink partition. And this, again, allows us greater scalability in systems managed under PowerVC. Now, what I will point out is when we bring this to the table, we can start playing around, if you will, in some of the new software-defined features. So we can actually utilize software-defined networking if we so choose on this NovaLink partition. But for the most part, bringing NovaLink to the table in a very basic Power VM configuration means I'm still doing things business as usual. I'm still virtualizing through my virtual I/O servers, but NovaLink is there for my virtualization management focal point. And all 3 operating systems are supported on our Power VM hosts. Now, where I really start shifting gears is when I start talking about this whole concept of software-defined. So we've got the last edition of PowerVC IBM Cloud PowerVC Managers for software-defined infrastructure is a additional version of PowerVC that supports a very different configuration of virtualization on our Power hosts. Now, this first example is still a traditional Power VM-based host. You'll notice the NovaLink partition is still there in that diagram, but we're missing the virtual I/O servers. And that's because in this configuration, we're no longer virtualizing our network and our storage through VIO. We're actually virtualizing it through the NovaLink partition. So as in with a VIO, the NovaLink partition owns physical resources like fiber channel adapters or network adapters, and it's responsible for virtualizing those to our client LPARs in the system. Now, when we bring this along, this is where we're going to introduce a product that Joe mentioned at the beginning when he was doing my introduction, known as IBM Spectrum Scale. This is the product formerly known as GPFS. It is a high-performance shared file system with a lot of other additional capabilities, far beyond what we can get into here in this presentation. But suffice it to say, it from a PowerVC and a power perspective for what we're talking about here, high-performance shared file system, single namespace is really what we're talking about. So this Spectrum Scale software brings this shared file system brings it to the NovaLink partition on that Power VM host. And from that shared file system, we can now create file-backed disks that are shared with our client LPARs. And in this configuration, it can be a kind of a classic virtual SCSI type configuration. So we're no longer using NPIV. Now, back in a traditional system, you can create a file-backed disk from one of your virtual I/O servers, and that file can come from wherever on that VIO. So the whole concept of a file-backed disk in vSCSI isn't foreign. We've had that capability for a long time in traditional Power VM. Now we're kind of moving that over to a Linux-based virtualization management point, i.e. the NovaLink partition. So this NovaLink partition, it actually is going to utilize software-defined networking, which we're going to talk about here in just a second, for our networking infrastructure, and it's going to use software-defined storage or the Spectrum Scale software to virtualize these file-backed disks to our Power VM hosts. And from a client perspective in this configuration, they don't know necessarily that the host they're talking to is a NovaLink partition versus a VIO. It looks the same from a client perspective. Now I do have a little orange, yellow box there that says MSP, or Mover Service Partition. For folks who are familiar with doing live partition mobility, you know that a virtual I/O server is configured to act as a mover service partition, or it's the thing responsible for doing all the memory shuffling and things like that across the network during an LPM operation. Under NovaLink, in this kind of software-defined configuration, we do have an option for a mover service partition for live partition mobility purposes. But as we'll see here in a few more slides, it's a little different implementation. It's not a full VIO like you're used to on a traditional Power VM host. I also will point out that the Spectrum Scale software is actually installed in the PowerVC server in this configuration. It participates in the Spectrum Scale cluster, mainly for quorum purposes, but also for file creation and cloning. So the Spectrum Scale software is part of the IBM Cloud Manager, IBM Cloud PowerVC Manager for SDI Edition. But there's no requirement for any sort of configuration, setup, etc. of the Spectrum Scale software. It's completely handled by PowerVC. We'll touch a little bit more upon that later. Now the last one we're going to add here is the new kid on the block. So this is for our open power-based systems that run only Linux, and are based on designs that we've put together with our open power partners. These are the systems that can run KVM natively on the Linux running in the bare metal. So it could be Ubuntu, could be Red Hat. This is a Linux client virtual machine only. So no AIX, no IBM I in a KVM on power environment. It is strictly a software-defined storage and software-defined networking story. So Spectrum Scale can be running there, and SDN is handled through the physical adapters that are owned by the host operating system or that Linux operating system running on KVM on power. I'll point out just from a diagram perspective, I've got the Spectrum Scale listed both inside these last two hosts as well as externally, SAN or iSCSI. So you can go one way or another. You can use storage-heavy-based nodes for these last two type of hosts, systems that have a lot of internal storage. And we can create that Spectrum Scale file system across those internal storage drives. Hopefully you've got at least 3 systems to keep 3 copies that maintain availability. Or we can utilize a SAN or an iSCSI-based infrastructure for acquiring those external storage pieces. And Spectrum Scale software works on both. PowerVC's implementation requires it to be one or the other, and you have to decide up front. So you can't mix and match internal storage and external storage, and you can't switch over if you decide you want to change how you do things. So I kind of touched upon this already, But some more details about this IBM Cloud PowerVC Manager for SDI. You heard some of the differences in what it brings to the table with regards to networking and storage. It is really the first version of a local private cloud on Power that we could truly do without any sort of SAN-based storage, if you choose. So you can bring in the like a SA12LC or S912LC box that has a number of internal drives, and you can create these a private cloud Ethernet based only between the nodes. So we call it a shared nothing or an FPO model in Spectrum scale terminology. The software that is included with this SDI edition is the PowerVC software that we've talked about so far, but also that Spectrum scale what they call the Data Management Edition license, and that's up to 2 terabytes per socket on a per server basis. That's included when you purchase this particular edition. And again, everything as far as the software install or configuration of Spectrum scale is all completely handled within PowerVC. We're no longer using VIOS with this particular configuration. It is KVM on Power. So we had a product called Power KVM. That's gone. We've withdrawn that from the market. The KVM story for running on Ubuntu or Red Hat is strong enough now that we don't need that Power KVM product. So this is KVM on Power only, Ubuntu or Red Hat. And then there's some system firmware or NovaLink levels depending on what kind of implementation you run. Kind of a quick summary of those editions. The SDI edition being the one we just recently talked about. Again, Linux only in that configuration, unless you've got that SDI implementation on a Power VM-based system, in which case we will go ahead and support AIX and IBM I as a tech preview right now. If you've got AIX Enterprise Edition on license for your servers, it includes that IBM Cloud PowerVC Manager. If you've got one of our cloud-based C models, it includes IBM Cloud PowerVC Manager. So it's out there. The Cloud PowerVC Manager for SDI is the special edition if you want to utilize that on our storage heavy nodes, or maybe you want to do a SAN-based model. So what is software-defined networking? What is the stuff we brought to you with this SDI edition? So let's talk about that a little bit here. The key here is that we have a programmable software-based switch. We use the Open vSwitch technology that's out there in the industry. We utilize that on Linux. So in this diagram, the host is, it's the physical server that's running one Linux operating system acting as our hypervisor, and then all our virtual machines are created within that using KVM-based technology. So this programmable switch or Open vSwitch, it allows us to create what are known as overlay networks, and we can do, and we'll talk more about that on the following slides. But basically, I can create new network definitions and quote unquote instantly put these things into place in my environment without necessarily going and working with my networking folks to get everything going. I don't have to recable things. I don't have to go out to the switches and create VLANs. We'll kind of see a little bit more about that on the next slide. These overlay networks, if we want to bridge them across our enterprise, and we don't want to make any changes along the way, we utilize what's known as an L3 gateway or a network node in PowerVC terms to handle the conversion, or if you will, the wrapping and unwrapping of traffic as we traverse the WAN environment for networking. We utilize an Ubuntu 16.04 network node today, and PowerVC acts as the controller. So it's the one who's in charge of not only programming these virtual switches, but also programming the L3 gateways as well. So he's the person in charge, if you will, from an SDN perspective. We don't at this point in time have any sort of integration with third-party SDN implementations where they have their own controllers. This is completely driven by PowerVC for Power servers. Now that programmable virtual switch can implement quality of service rules. So our workloads on the far right-hand side, those are virtual machines. And those workloads can be, given, a certain percentage of the traffic through that programmable virtual switch. We can also implement security groups. So you can think of that as a, firewall, if you will, within the switch itself, rather than running in the individual workloads. And those security groups can be defined across, multiple systems. Systems can belong to multiple security groups. And you can say, hey, these systems, they only get, port 80 and port 4430 traffic. So, they're just doing web browsing or HTTP type functionalities. So you can program all that into those security groups, and it gets immediately put into place into the programmable virtual switch or the Open vSwitch via PowerVC. So when we talk about overlaid networks, or VXLANs as they're called, it's actually a pretty familiar concept or technology. We're all familiar at home where we've got our internet access point at home, typically some kind of cable modem or Wi-Fi router, et cetera. And that Wi-Fi router provides us with local, what we call Class C non-routable networks. So in the example here, 192.168.1. something, right? We're all familiar with that. We get that at home. But then we go through the router and we go out into the wide internet as a whole, and 192.168.1 IP addresses are non-routable. They won't go anywhere on the internet. They're designed for local access only. And so our router, or in this case, the example of the gateway node, handles the wrapping of traffic, or natting of traffic, network address translation of traffic, so that our communications work out there in the internet, and we're able to get information back, and it comes back to us. So it's very similar in concept to that. This gateway node handles that functionality here. And so in the example diagram, I've got these non-routable networks defined on two sides of the enterprise, if you will, or two hosts, or two sides and groupings of hosts. And they're on the same network definition, but the network isn't actually defined out there in the middle cloud, the network cloud in the middle. The gateway nodes handle all the network address translation and the passing of traffic back and forth, so they know where to go. And so I can define these networks very rapidly. They look like they're on the same network on both sides, and they can communicate. Now, these are non-routable IP addresses. You can define real IP addresses if you want. It doesn't matter, since these networks are effectively only visible within the software-defined networking environment. They're not visible out there in the cloud network in the middle. Now, what if you want to do? You've got these software-defined networks, but then you need a real network IP address. You need something real on your local customer environment. Well, we can set up floating IPs. So these floating IPs can be assigned to individual workloads. They can be set up so that they fail over between workloads if one of the LPARs goes down, for example. But the idea is that when traffic comes into the gateway node destined for 100.101.1.1, that traffic is going to get routed to the proper virtual machine to be able to receive that traffic and then communicate back. So, the example is maybe you've got a database running there that has to be able to communicate with the outside world. And so you can put one of these floating IPs and define it within PowerVC and assign it to that particular workload. Now, this isn't really software defined, but this is something that is available and manageable from PowerVC. We've had SRIOV available on Power Systems for quite some time. This is single root IO virtualization capability. So this is effectively virtualization at the adapter layer within the hardware. Initial implementations of SRIOV didn't allow for live partition mobility. And so a couple of years ago, we introduced the virtual NIC, or VNIC technology, which, as you see from the diagram, looks a whole lot like the old traditional virtual SCSI type configuration, where we've got VNIC client adapters, VNIC server adapters in our VIOs, and our end client LPARs. They'll actually do their data communication directly to the SRIOV adapter. They don't go through the VIOs. That's just the control flow path. The idea being is not only can I virtualize at the adapter layer, but I can get higher throughput and performance of the assigned traffic, and I can even set up quality of service and things like that within SRIOV. And initially, when we implemented this under PowerVC, it was NovaLink management only, and then now we've actually expanded that into the new release that becomes available tomorrow. That will actually support HMC configuration of SRIOV adapters. It is pretty much just an AIX, mostly an AIX story today. There is some limited Linux support and very recent levels of Linux as well, and no IBM I support for the SRIOV VNIC capability today. But we can configure VNICs in PowerVC, and that will allow us to do live partition mobility operations using the SRIOV adapters. So I've mentioned live partition mobility, and just so folks understand, what I've got here is an example of a first system on the left-hand side. It's Power 8 server. It's configured with NovaLink. It's running PowerVM. Second server is KVM based, so KVM on Linux. The last server is for just an example, a Power 9 server running PowerVM, HMC managed, so not NovaLink managed. And so, as I mentioned before, and that should not be surprising, there is no concept of partition mobility between hypervisor types, so we can't move an LPAR from PowerVM to KVM, and vice versa, can't move something from KVM to PowerVM. Just as an aside, if you've got both types of KVM in your environment, there's no live partition mobility between RHEL KVM and Ubuntu KVM, but that's probably a different story there. But obviously, I can move from a PowerVM system managed under NovaLink to a PowerVM system managed under an HMC. So that capability is there, and that's been there for a while, so we can do that. And what's not drawn in this diagram, but what is important is there's no live partition mobility between what I would call the traditional SAN and the SDI implementation. So if you think about a SAN-based infrastructure, live partition mobility works because the WWPNs, are available and zoned to the other, available on the other host as part of the live partition mobility operation, so that the storage is available on the destination host. When you've got disks that are coming from a file-backed shared file system and disks that are on the SAN, there is no movement between those two via live partition mobility. But we do have a story that might help you move things around if you want to use it. I'm just going to touch upon the next couple slides rather quickly. This is that NovaLink SDI mover service partition, just for folks who understand. This mover service partition under NovaLink is based on a virtual I/O server, but it's not open. It's not something you can log into. You're not given the password. And in fact, these sample commands here show what a system looks like under NovaLink management. This PVMCTL command is a NovaLink command line command. I'm listing virtual I/O servers on a box. Before I create this mover service partition, I run the command to create it, and then afterwards I actually see this mover service partition running in my given environment. Now it lists the NovaLink partition as a VIO because it is a virtualizer of I/O. So that's why it's listed under the VIO list here in this particular example. And in the PowerVC interface, after things have been created properly from a mover service partition capability, I'll go ahead and see that within the PowerVC UI as well. Again, Spectrum Scale completely installed, configured, etc. under PowerVC. You don't have to learn Spectrum Scale commands to have this running and working. And in fact, when it comes time to update the software, the underlying Spectrum Scale software, all you have to do is basically download the patch set, put it in the right directory on the PowerVC server, and he'll go ahead and notice, hey, by the way, there's a new version of software out there. And I can click on the Update Spectrum Scale button, and he will do a rotating or a rolling upgrade through the Spectrum Scale cluster environment, starting with the PowerVC server, then with your first Spectrum Scale KVM SDI node, putting it into maintenance mode, moving the LPARs around, etc., until that software has been updated across all the servers in the environment. So it's kind of a nice functionality to not have to deal with that. If you're using SAN-based storage and you want to grow that spectrum scale file system, you can add those disks on the storage. You can do that through PowerVC if you want, and then we have a nice little click through that says, hey, add this to the spectrum scale file system, and I can grow my file system that way. For folks who like to see where things are, I just included this, that when we create file-backed disks under spectrum scale in the SDI configuration, this is the path we place things into in that shared file system. From a PowerVC perspective, the fact that we're managing PowerVM via HMC, PowerVM via NovaLink, or KVM, it all looks the same at the high level on PowerVC. I mean, yeah, there's details that are different, but it really does look the same. We're not going to, have a totally different user interface for KVM on Power versus traditional HMC managed PowerVC infrastructure. So I kind of already mentioned these things. These are some installation steps. I did mention we can't move from spectrum scale to traditional SAN storage, not via live partition mobility, but we have introduced what we call image agility in PowerVC. And so this is an ability to take images. You capture an LPAR, we've got an image now. Taking that image and either exporting it from PowerVC to a local file on my disk, or maybe even exporting this up into a object-based cloud storage infrastructure somewhere. So this could be utilized for backup purposes of images. This could be used for DR purposes. If I want to take images from my existing production environment, capture them in PowerVC, export them, and bring them over to DR and re-import them on the other side. This allows me to, unlock the image from the storage it originally came from. So I mentioned before we're making copies of LUNs in the storage array. If I want those copies to be on another storage array, well, I got to find a way to do that. And the image agility capability in PowerVC allows me to do that quite easily. So I've got I kind of already mentioned this. Now VIO shared storage pools, they're kind of over on the side with this. So VIO shared storage pools don't participate in the image agility capability. Although we do provide documentation within PowerVC that says how you can go about effectively writing into a file back disk in the VIO shared storage pool, or reading from that file back disk. This also is kind of the underlying technology that's utilized for the IBM Cloud for SkyTap solutions. Just if you haven't seen that before and are interested, this is effectively a lift and shift of AIX LPARs from your on-premise environment into the SkyTap cloud, if you want to see what that involves. But it's utilizing the same underlying technology of effectively capturing a LPAR on your system there and taking that image and transferring it over. And so there are differences between the graphical user interface and the command line. I'm not going to get into these in great detail here. You can see take a look at the slide, but effectively, one allows you to go to local files that are exportable, i.e. in what we call an OVA package, or Open Virtualization Archive package, or a tarball. And that's exportable and can be carried around, so I could transfer that file over to another system and re-import it. The backup repository is specific to a particular PowerVC server, so that's where it could be a local set of files written to, or it could be an object, OpenStack object-based storage or Swift storage array as well out there in the wide world. And there is a requirement, if you're doing this for SAN-based storage, that your PowerVC server is connected to PowerVC managed SAN, because when we import and export these images, we're in the case of SAN infrastructure, we're attaching LUNs, image LUNs to the PowerVC server, reading those off, writing them out to a file, or in the reverse process, reading that file and writing it off to a locally attached disk, or a SAN attached disk that comes from our SAN storage array. So our PowerVC server must be connected to that PowerVC managed SAN in that configuration. So why even talk about any of the software-defined stuff? Just real quick, these are kind of my thoughts on it. The software-defined networking is quite easy to use, and it's quite flexible. And you know, the fact that you don't necessarily always have to get your networking folks involved can be a benefit, especially if there's some really hard silos there. Why the software-defined storage? Kind of the same story, actually. In some customer environments, you can't. There's no authorization for the systems folks, i.e., the folks running PowerVC, to be able to talk to the storage infrastructure, be it the SAN or the storage arrays. I call it impenetrable silos is how I define that. So, you know, if you've got that kind of configuration, you're going to need something to make this work. VIO shared storage pools is an option, although in some customer environments they don't care for it, or maybe there's too many limitations with the number of systems you can have in a VIO shared storage pool cluster. Or you're looking for a low cost of entry, really quick and easy to get set up local private power cloud. So you bring in, 3 S912LC models, and each one filled with disks, and then I just have a network connection between them, and I can create a local power cloud for my Linux-based virtual machines, if I want to do it that way. And yeah, if you're looking at implementing Linux only for certain functionalities, then certainly we can utilize that utilizing KVM on Power, and not necessarily going with Power VM because we don't need it. The enterprise requirements and things like that aren't there. So I said I would mention IBM Cloud Private kind of here near the end of the presentation, though. So what we've provided, and there's other things that go along with IBM Cloud Private. It's a fairly expansive portfolio. But one of the things we provided from a PowerVC perspective was this concept of a flex volume driver. So if you're not familiar with IBM Cloud Private or Kubernetes or Docker, you've probably heard of Docker containers. Kubernetes is an orchestrator of Docker containers in an environment, and IBM Cloud Private is IBM's implementation of Kubernetes. And so there's a couple concepts. You have worker nodes and master nodes, and your worker nodes are your operating systems running the Docker software that create these Docker containers. So these are these microservices or these shared elements that run the software within the Docker containers. And by default, these things all use ephemeral storage, and sometimes you want real storage attached to your Docker containers, something that's going to be a little bit more permanent. And so what we created was a flex volume driver that runs. It's part of Kubernetes. It's implemented through IBM Cloud Private, and just like PowerVC can talk to the storage to create disks and create LUNs and things like that, same concept here. The ICP, this flex volume driver has a provisioner that runs on the master node. The master node talks to PowerVC, tells it to create volumes, attach those volumes to the particular virtual machines, and then the flex driver running on that virtual machine, in the case of Power VM, can then attach that storage to the Docker container. So it's kind of a three-part deal there. And of course, like I said, there are other ways of attaching storage to Docker containers. I'm not going to get into all this here, but this is just an example of PowerVC's, effectively it's northbound REST APIs being utilized by other products. In this case, it's another IBM product, IBM Cloud Private. Just real quick, that's the service strategy for PowerVC. So we actually just announced this and changed this as well. But we've got a full 5-year support stream for the current releases of PowerVC. So those things are out there and available for you. And we're up to version 1.4.1 is the version you can order today. 1.4.2 is the version you can order tomorrow, or it actually becomes generally available tomorrow. So it should be available for download tomorrow if you want to play with the latest release. And I'm actually going to skip over the requirements part. This stuff is all kind of here for reference. And Joe, maybe as I switch over to see if my live demo is still running there, you can shout out a couple of the important questions from the question queue.
Let's see here while you're doing that. There were several questions up front about shared storage pools and how that works with PowerVC supported and limitations and such. So shared storage pools are supported within PowerVC. In fact, when we add a host into PowerVC where a shared storage pool has already been defined, we pick that up automatically. So the shared storage pool automatically becomes visible within PowerVC, and we treat it just like another storage array. So you create disks out of it, just like you would do on the command line of VIO shared storage pool. So you do like an LU, create and things like that. We're going to create disks, file back disks out of the shared storage pool. We're going to allow you to capture and deploy LPARs that utilize those disks within the shared storage pools. And really, all the functionalities you saw, maintenance mode, live partition mobility, advanced remote restart, all those capabilities work under when the storage is VIO a shared storage pool. So it's really, for the most part, it's very equivalent. Like I said, you can't LPM from a system where your storage is backed in a shared storage pool to SAN because we don't have storage migration in PowerVC. Just virtual machine migration. All right. Okay. I do see your live demo up there. It's still running, right? It looks like it. Hey, look at that. What do you know? Right. All right. So you want to take one more question, or go ahead and no? Why don't you go ahead, and then when you're done, we'll see what we have left, and you can bring up the questions. We'll go through them. All right, sounds good. I'll try to make this short. For folks who haven't seen it, this is the PowerVC user interface here with our nice overview of the resources in our environment that we're managing under PowerVC. Just to give you an idea, I've got 5 physical servers running here. One of them is HMC managed. I've got 2 under NovaLink management, traditional SAN-based storage here. And then I've got 2 software-defined nodes. So I've got a software-defined node running PowerVM, and then I've got a software-defined node running KVM. So I've kind of got a little bit of everything from my earlier diagrams and my presentation slides, although most of my resources, as you can see, kind of run in my more traditional environment just from historical purposes. Nice little summary of all the processor and memory allocation that I've got in my environment. Thankfully, everything looks green on this screen. If I wanted to kick off something like a maintenance mode, I can do that quite easily from within the graphical user interface. I'm not going to do that. If I want to bring on board virtual machines that are out there that aren't under PowerVC's control, I can do that as well by clicking my Manage Virtual Machine Resources. I've got dual HMCs out here. I don't remember if I've defined my second one yet. But if I did define my second one, I could go ahead and move over to my second HMC if I wanted to. So there's my dual HMC support. I've got a couple host groups out there. My default host group is kind of everybody else, and then I've got a NovaLink host group. So this is my traditional NovaLink systems, and I've put in a different CPU utilization policy there as well in an advisory mode for DRO or dynamic resource optimization. Got a whole bunch of, well, not a whole bunch, but I've got a number of LPARs out here. Here's one I actually just recently created for this demonstration here. So I've got my VUG LPAR. You can see my LPAR resources, CPU and memory. Network configuration here. Where it was deployed, what operating system's running at it, all the wonderful details you would expect to see. And then if you'd like to see all the continued stuff about what OS is running on it, sharing mode, all the min-max stuff, etc. That's all out there. I've got just my base operating system disk. Nice piece of PowerVC is being able to click the attach volume button. And I can just come out here and I can create a brand new disk
on my storage array, attach it to my LPAR. And I apologize for the scroll bars because of the font size on the demo, which I usually increase to make it a little bit more legible. There's quite a few more scroll bars on this. But it's really that easy. I've gone ahead and told him to carve out a brand new disk from my V7000 storage array. I've got two behind it. He's going to go ahead and carve it out and then map it to my client LPAR, and it'll take just a minute or two for that to happen. For NovaLink managed systems, I've got this nice convenient LPAR console here. So here's my out-of-band console, and I could log into that LPAR if I want to. Yeah, there's no password on here. This image is based on the downloadable AIX Cloud-ready image that we have available from the entitled software download site. So if you're familiar with that, that's what this image comes from. So it's a fairly recent level of OS. So like I said, stopping, starting, deleting. I can capture it if I want to. I can migrate it. What's kind of interesting is I don't have to migrate it to a particular place. I can say, just get it off this box, but do it based on the policy that you've got in place. So I can do that as well. Now, in my quick example, this is all I'm running as a particular user using the default project here. But if I log in to here as a self-service user, so this is that Cloud PowerVC Manager component, you can see a much more simplified user interface. So I've really only got images or deploy templates and virtual machines, and I don't own anything right now. So I'm going to click back on my LPAR definition here, and I'm going to make him owned by student 1, give him an expiration date of the 31st, 2019. And then if I come back over here, I see so my student 1 actually owns this LPAR now. So this is that concept, that self-service simplified interface. I've got a deploy template here, not very much detail that I can specify. I can just say I'd like two new LPARs, and I can call them mine, and I can put a description in here, and I can request. Can't type. Request a couple LPARs from my cloud administrator, and now it shows up in my queue as a pending operation because I put in place the fact that I need to approve or disapprove of individual requests coming in. I'm the administrator over here. I can take a look at this. I see the request that came in. I see the user message, right? I can approve or deny it. If I say approve, you're welcome. And then I can send that message back. And I didn't talk about it, but we do have integration with email and notification capabilities. So if you want to be able to send a message when that request comes in to an administrator and send a message back off to the requester, we can do that as well. So what you'll see happen here is he's in the process. Remember, I gave it a name of mine. He's going to, since I asked for 2, he's going to go ahead and initialize the creation of those 2 brand new LPARs in my environment. And if I wanted to, I could come back here and I could see mine. There we go. So they're both currently in the process of being built. He's going to pull an IP address out of the IP address pool. Now the simplified user interface, you can see there weren't a whole lot of options. If I was deploying as an administrative from the regular interface, I'm going to have quite a bit more flexibility with regards to what I can do. I can choose a particular target to deploy that image to. I can integrate an SSH key pair. I can change my compute resources to what I need them to be. I can add additional storage volumes as part of the deploy. So if I have a simple image and then I want to add some blank disks that I'm going to use for database, I can do that. There's my networking information, and if I want to pass some cloud init information, customization information directly to that particular deployment, I can do that as well down here at the bottom. So this is there's a lot of capabilities that kind of make it easy, and I guess I've got 4 minutes left, Joe. So let me actually go ahead and stop the demo right here, and we'll see if we can pick up a question or two.
Okay. Well, let's go ahead and talk about the NovaLink and the HMCs for a minute, because there were a few questions on that, Glenn. So if you have NovaLink, you're really replacing the HMC there, right?
For virtualization management only. The HMC is still used for all the non-virtualization management pieces.
Okay. And then if you have NovaLink there and you're not using the VIOS, there were questions on whether you would have, like in VIOS, you would have dual VIOS for redundancy. How does that work when you replace it with NovaLink? In your pictures, I noticed you showed just a single NovaLink.
That's correct. Today we don't have a dual NovaLink type configuration. So it's for a different class of workload than we would traditionally have in the dual VIO types configuration.
Okay. Let me see. So there were some questions too then about, let's see, it was, can the NovaLink be on outside of the Power server?
No. So the NovaLink runs inside the Power server, and in the case of, it's actually utilized to talk, in the case of Power VM, it's utilized to talk to the hypervisor inside the box. Okay.
And let's put that same question sort of towards PowerVC, because we got PowerVC running on a Red Hat Linux partition, right? And that could be in a Power server somewhere, or or it could be on an Intel server.
Correct.
But
so that obviously, you know, if you're running your PowerVC server on your Power box, you want to make sure you didn't do something like, you know, tell PowerVC to shut down your PowerVC server, right?
Right.
Typical self-referential single point of management there. So yeah, you could run it outside. You know, if you're running in an x86 virtual machine farm, you can use whatever high availability capabilities come with that, and so forth. But we don't have a highly available PowerVC server. But if your PowerVC server's down, for the most part, everything still just continues to operate. Just like if your HMC goes down, you know, your LPARs are still up and running. We do have the capability of backing up all the PowerVC data and leaving that you know, sitting aside somewhere where you can easily and quickly restore that if you want to.
Okay, so I'm just trying to clarify some things where some questions came in, and so I get all that. Then now your PowerVC server though is really just managing the Power System VMs. It's not managing, even though it could run on an Intel system somewhere, it's not managing any Intel VMs, correct?
No Intel. It's all in the name. It's all Power-based, correct.
All right, but now vRealize can manage Power VMs as well as it manages the Intel, but the whole point of vRealize is that you can use that to also manage your Power LPARs.
You would use it at a high level to have a view of your Power Cloud along next to your x86 cloud, and it will all show up in the same UI on the VMware vRealize side.
Okay. I think the question really was what management. I mean, what you just said is it kind of shows you what's out there. What kind of management can it do of them though?
So I'm not
management of the Power.
Yeah. I know the vRealize automation can do the deployment piece. I'm not as familiar with the vRealize orchestration or the brand new VROps capability. So I know each one of those has added additional levels of ability to manage the Power environment. I just haven't had my chance to get my hands on all that yet.
Okay. So I'm going to give you one more here. Since we're sort of 11:30, I'll give you this last one. This is the question is, why does PowerVC distinguish between data volumes and boot volumes, and the benefit that provides?
Good question. It comes down to image capture and deployment. So if you think about it, if you have operating system disks and data disks, to successfully duplicate and i.e. capture and then deploy, create new, an OS or a virtual machine, you need your operating system disks. Your data disks are optional. So that's what it comes down to. Your boot disks have to be captured as part of an image capture and deployment, whereas your data disks are completely optional.
All right, perfect. Thank you, Glenn. And you know, I didn't expect you to do the demo. That was a very, very nice, kind of like icing on the cake. You did a great job. I really appreciate you doing this for us.
You're quite welcome. Thanks for having me.
So everyone, that wraps up for our 2018 Power Systems Virtual User Group webinars. Again, Merry Christmas to you all. Happy New Year. And I'll be sending out invites next year for new webinars. With that, so long.
Okay. So, Joe, do we have the question log that I can answer the questions and you can put it up there with the replay?